In this video, we're going to look at some exponential and logarithmic equations. It's going to be kind of our introduction or our first video, and so we're going to work 3 problems in this video. This is what I would call an easy problem. We have 5 raised to some power equals 13, but we don't know what that power is. We know 5 to the first power is 5. 5 to the second power, 5 times 5 is 25. So it looks like it's going to be some number in between 1 and 2, but we don't know what it is. And so we can use logs for this situation. And so what I'm going to do is I'm going to rewrite this in log form. And actually, before I do that, let me come over here and make sure we all know that if I have a to the x equals b, then I can rewrite that in log form as log base a of b equals x. And we need to be fluent in how to go from what we call exponential form to logarithmic form. And so that's what I'm going to do here. I'm going to take this from this exponential form and we're going to rewrite it in logarithmic form. So that 5 is the base, 13 becomes the argument, and then that's equal to x. And this is really something you can just punch into your calculators. If you don't have a calculator that can do that, then you can use the change of base formula, which I'm not going to go into in this video, but that would just be typing in log of 13 over log of 5 in your calculator. And what that comes out to is it comes out to roughly 1.59, which is our solution there. Let's take another one. This one's slightly more difficult, still not super hard. So what we have here is we have e to the x squared equals 100. And so I'm going to start by looking at this. And since we have that base of e, I'm going to take the natural log of each side to kind of undo that. So if I have e to the x squared equals 100, I can do anything to one side as long as I also do it to the other. So I'm going to take natural log of e to the x squared equals the natural log of 100. And one of our properties that we learned about logarithms in a previous video is that if I have, like, let's say I have log of x to the y, that's equal to y log x, meaning that exponent can kind of come out in front and be a coefficient. And that's exactly what we're going to do right here with this x squared. It's going to kind of come out to the front, and then we've got our natural log of e, and that's going to be equal to the natural log of, oops, let's be color-coded here, of 100. Now, why this is important and why we did that is these two right here are inverse operations. Taking the natural log of something and e are inverses, so what happens is those pretty much cancel and become a 1. And so now we're left with x squared equals the natural log of 100. And now we're just going to solve for x by taking the square root of each side. And we get that x equals plus or minus the natural log of 100. And that natural log of 100 is going to become plus or minus roughly 2.146. And that's a rounded number. Okay? Let's do one final example. And this last example I think is a little bit tougher. Let's look at a little more difficult of an example. So here we have e to the 2x plus 1 times e to the negative 4x equals 3e. Now, here, whenever I'm multiplying two powers that have the same base, hopefully remember from Algebra 1, if I have like x to the third times x squared, that's x to the fifth. We add those exponents. And so that's exactly what we're going to do on the left side of our equation with those exponents. So if I do e to the 2x plus 1 plus, and then I add that negative 4x, that's going to be equal to 3e, and then I just have some like terms to combine in my exponents there. So I end up with e to the negative 2x plus 1 equals 3e, which is really 3e to the first power if there's no exponent on there. And now what I'm going to do, and this is one of those where I just have experience doing a lot of problems like these. I don't know, I'll say the more you do, the more you're going to see this sort of thing. But what I'm going to do is I'm going to rewrite this in logarithmic form. Okay? And so let me show you how I'm going to do that. What I'm going to do is I'm going to, like we did in a previous problem, I'm going to take the natural log of each side. So I'm going to take the natural log of e to the negative 2x plus 1, and that's going to be equal to the natural log of 3e, and I'll just put that little 1 exponent there. And what happens is, once again, I think this was our problem number 2, that exponent can become a coefficient out in front. So I have negative 2x plus 1, okay, times the natural log of e, and that's going to be equal to the natural log of 3e. Just like the previous problem, natural log and e are inverse operations. And so what that leaves us with is negative 2x plus 1 equals the natural log of 3e. And now what I'm going to do is I'm just going to isolate the x. I'm going to subtract 1 from each side, and then I'm going to divide by negative 2. And we should have our answer. X equals the natural log of 3e to the first, but then we subtracted 1 from each side, and then we divided by negative 2. And this is really our expression, and I would just type that whole thing into the calculator, and what you end up getting for your solution is x equals negative 0.549, and once again, that is a rounded amount.